Hey Team Electronics and Coding, welcome to your homework. It's going to be an introduction to for loops and PWM, or pulse width modulation. Okay, we're going to introduce some new variables as well as some new functions, as well as review some old, and then we're also going to talk about this concept of PWM, or pulse width modulation, but more on that later. Okay, let's start from the beginning with some variables. An old variable, we have talked about this variable int before. This stands for integer. So this is a variable, when you create it, that can hold any sort of whole number. You know from your code, when we had two lights and a button, that this integer, we stored the value of the reading of the button in a variable that we created that was an int variable called button state. It was a whole number. It could either be 1 or 0, high or low, if the button is pressed or unpressed. And it couldn't change. So over the course of the sketch, it could be 0 if the button was unpressed, or it could be 1 if the button was pressed. So an integer is a whole number that can change over the course of your code. This next variable type is called a constant int, or a constant integer. It is also a whole number. So it can be 0 or 1 or 2 or 3 or 100. But unlike a int, a constant int cannot change over the course of your sketch. So if you set it equal to 2, then it's going to stay 2. So integers are whole numbers that can change, and constant integers are whole numbers that can't change. You're going to see some of the purpose of constant int in the sketch we look at next class. Okay, we've briefly introduced if-else statements, but just to review, an if statement contains within its parentheses a condition. We were checking to see if A was equal to B, if the button state was high. And then following the if statement was a code block. There was also an else statement that followed the if, and inside of the else curly braces was another code block. When we look at the structure of this type of function, an if-else, we can see that we have code that comes before the if statement here. In our case, it was a digital read of, I think, pin 2 or 3 that we had the button plugged into. We stored that variable or that value in the variable button state. And then we proceeded to our if statement. We had a condition. If the condition was true, we executed the code that was within the if code block. If the condition was false, we went to the else statement and we executed the code that was within the else code block, and then proceeded on to the rest of the code. So we went to the if statement. If the condition was false, we jump down here and do this. If the condition is true, we do this. And here's kind of a graphic laying this all out for you. Okay, so I explained this again because I want to talk about a new structure, which is called a for loop, which is a little bit more complicated, but I think you're going to get it. At first, I'm just going to write down the arguments of a for loop in the code block, and then I'm going to talk you through the graphic, and it's all going to come together and make sense. So just have a little patience. Okay, so here I'm going to write the first argument of a for loop is the initial value. Of a variable. So in our case, let's say we set it equal to I is equal to 0. Our next argument is the condition. For us, we're going to say I must be less than 4. And our last argument is the increment. And let's say I plus, The increment for us is I plus plus. This is the same thing as I equals I plus 1. Okay, don't worry. This is all going to make sense in just a second. And then after the for loop, we have our code block. Okay, let's talk about what this actually means. So we start with our initial value. So here we have some code preceding our for loop. Let's say we have some code. And we reach our for loop. So we have this structure: for I equals 0, I is less than 4, I plus plus. The first thing we do is we start with our initial value. I is equal to 0. Then we check the condition. I must be less than 4. If I is equal to 0, which we started it at 0, and I is less than 4, or the condition is that I must be less than 4, then right now the condition is true. And so we're going to execute the code block. So we go from checking the condition to executing the code block, and then we increment. I is equal to I plus 1, or I plus plus. These two things are equivalent. Means that we're going to add 1 to our value of I. So now our value of I is equal to 1. So we go back up to the condition. We check to see if the condition is true now that I is equal to 1. Well, 1 is still less than 4. So we execute the code block right here. Now we increment by 1 again. So 1 plus 1 is 2. Now our new value of I is 2. 2 is still less than 4. So we execute the code block. Then we add 1. Now I is equal to 3. We go back up. We check the condition. 3 is still less than 4. We execute the code block. I should have made this smaller. We increment again. Now I is equal to 4. We check the condition. 4 is not less than 4. So now we exit the for loop. The for loop is over. We do not execute the code block anymore. We proceed on to the next line of code. Okay, you're going to see a for loop in class tomorrow. So if that was confusing to you, you should watch it again. Okay, the last thing we're going to talk about are two functions, one that we've talked about before and one that we haven't talked about before. Analog and digital write. We have talked about digital write. Digital write is a function that takes two arguments. The first is the pin number, so the pin that the Arduino is connected to, and then the next is a value, a digital value, so which could be high or low, or you could write 1 or 0. Those two things are equivalent. So digital write takes two arguments, the pin number, and then high or low, 1 or 0. If you say digital write pin 3, 1 or high, that means you send a voltage of 5 volts to that pin. If you write digital write pin 3 low or 0, that means you write 0 volts to that pin. If we're looking at an image right here, this would be writing low to a pin, and this would be writing high to a pin. This is a kind of graph of that showing. So either you're writing 0 volts or you're writing 5 volts. So the Arduino is a component that can't write or can't apply a voltage to any component that is less than or greater than 5. It can only, out of the pins, the digital pins, the I/O pins that we're using, which are 0 to 13, it can only be high of 5 volts or low of 0 volts. It can't write anything in between. However, we can kind of mimic an analog output by using a function called analog write. Remember, a digital output is something, or digital whatever, has two values, 0 or 1. Whoops, that was another 0. Analog has a range of values. So if we analog write, so the function analog write takes two arguments, the pin number and a value between 0 and 255. We'll talk about where this number 255 comes from sometime in the future, but not today. For now, all you need to know is that analog write can be any number between 0 and 255. If you analog write pin number 3, the value 0, it's equivalent to saying digital write pin 3 low. It writes a value of 0 all the time to pin number 3. If you write pin 3 255, it's like saying this. You apply a voltage of 5 volts to the pin the whole time. Okay, what about if you write some sort of intermediate value? Let's say you write a value halfway in between, like 127. Well, what that means is the voltage that you apply to a pin can't be, let's say, 2.5 volts, but what you can do is over a very short period of time, have the pin number 3 high. So for 1 millisecond, have it be 5 volts, and then for 1 millisecond, have it be 0 volts. And then for another 1 millisecond, have it be 5 volts, and another 1 millisecond, have it be 0 volts. This 2 millisecond cycle is called a duty cycle. And this represents a 50% duty cycle because half the time the pin is turned off, it's low or 0, and half the time the pin is high at 5 volts. Okay, so if you do this, if you analog write, let's say an LED, a 50% duty cycle, it means that the LED is going to be on for a very short period of time and then off for a very short period of time. On, off, on, off, on, off, and so forth. And to your eye, it's going to happen so quickly that instead of being like really rapid flashing epilepsy causing lights, you're going to perceive it as just a dimmer light because it's flashing on and off so quickly. Okay, if you write a value of half of 127, which quick math, 7 is, I can't do mental math while I'm 127 divided by 2. 63.5. Okay, so 64. So if we write a value of 64 if we analog write pin 3, the value of 64, we're going to get a 25% duty cycle. It's only on for half of a millisecond, and then it's off for a millisecond and a half. So it's going to appear much dimmer than it did at a 50% duty cycle. And then the opposite is true. Okay, right. Let's say 3 plus 127. If we write a value of 191, so analog write pin 3, 191, we're going to create what's called a 75% duty cycle, where for 1.5 milliseconds, the pin is at 5 volts, and then for half a millisecond, it's off. So this light will appear brighter. So if we write it high all the time, or a value of 255, then it's the brightest. If we write it a value of 191, it will appear just a quarter less bright, and then 127, it'll be half on, half off, and then this is a quarter on, 3/4 off, and then this is just off. So the reason I'm telling you all this is because using, and this whole thing is called pulse width modulation. Using this pulse width modulation, or PWM, we can mimic an analog output using actually a digital signal. This only has two states, high or low, but we get this whole range of variable output using pulse width modulation, PWM. Okay, that is all. The last thing is delay. Delay is a function that stops the code from proceeding, and it delays the program in milliseconds. It takes one argument, which is a time in milliseconds. There are 1,000 milliseconds in 1 second. So if you write a delay of 1,000, this means that it is 1 second delay. Okay, that's all.